Hi, my name is Alex Sesta, and today we're going to look at some YouTube videos, but we're going to do more than just laugh at these physics dummies. We're going to explain why they failed. This is the physics of Phails. First, we're going to look at the seemingly harmless playground equipment, the merry-go-round. Whether you feel it or not, you're experiencing centripetal force. The boy in the video failed for one simple reason. He leaned backwards. Well, maybe two. You probably shouldn't power a child's toy with a motorcycle. Anyway, the boy has a constant velocity sideways, but an acceleration towards the centrifuge, the middle. By leaning backwards, he broke the force of the railing, pushing him inwards, without even knowing it. The boy brought his fate upon himself. Without even knowing it, he broke the force, keeping him in, which then, he was launched from the merry-go-round with the force of the rotation of the ride. Based upon some assumptions, such as the diameter of the merry-go-round and the weight of the average person, we found that the boy was launched out of the ride at 13 meters per second, or 47 kilometers an hour. That's twice as fast as you should be traveling in the BCSS parking lot. We also discovered that the centripetal force was 9,040 newtons, and the boy was accelerating at 113 meters per second squared. That's like getting hit by a 2014 Audi R8 trying to go 0 to 60. Speaking of cars, we have a particularly funny video about a man trying to jump over a car, a physics dummy. Why? Why? This man experienced a very large impulse, which is a change in momentum. The man's momentum was far less than the car's momentum. So, the man experienced approximately 427 kilograms meters per second, the measurement of impulse. Even without knowing how large the impulse was on the man, one thing's for sure, that must have hurt. Third up, we have a trampoline fail. This is what happens when you don't apply spring energy and spring force correctly. Hooke's law states that the force needed to compress a spring by a certain distance is proportional to that distance. In this fail, the boy generates energy by jumping up and down. At the top of his jump, the energy he created by the spring now turns into potential energy. On his way back down, he regains kinetic energy. When he lands again, most of his energy is conserved by the spring. When his energy is returned to him by the spring, it could have been another jump upwards, but this time he jumped at a different angle which caused him to fly sideways. Most of his energy was delivered to him in the horizontal direction. Based upon our calculations, the boy traveled at 5.3 meters per second at an angle of 73 degrees above the horizontal. After finding the velocity, we can find the initial kinetic energy of the bounce, which is close to the spring energy. We determined that the kinetic energy, and therefore extremely close to the spring energy, was 1.1 times 10 to the 3 joules. Let's jump into the next fail, the faceplant. It's funny to everyone except the person it's happening to. This faceplant is related to the friction of the hill, or in physics terms, the ramp. When the woman loses her balance is when the grade 12 physics begins.
Kick it out! Kick it out!
When the woman falls and lands on her face, she loses most of her speed because of the friction that is doing work on her, and especially her face. Since the woman is traveling down the ramp, the force of friction is less than what it would be if she was traveling on flat ground, since the flat ground would be perpendicular to the force of gravity. We determined the average female weight and height, and then increased it slightly to account for the equipment. Using the woman's height as a scale, we determined that prior to falling, she ran approximately 3.8 meters in 2 seconds, and after falling, she slid 3.7 meters in 1.7 seconds. We were then able to determine that the net force was 36 newtons, and the force of kinetic friction was 428 newtons. That must have hurt. This video is brought to you by our unofficial sponsor, the Pixel Ruler app. Now, back to the Phails. Here's another faceplant, but this one's a little different. This one involves water and someone who has no idea about relative velocity. Looking at the first boy's jump, we know that he must have taken grade 12 physics because he executes the jump perfectly. But the second boy obviously wasn't paying attention to his friend. The boy failed because even though he jumped backwards, his relative velocity was still forward due to the boat's velocity. He didn't lean backwards when he jumped, so his weight was in front of the center of gravity. His velocity relative to the boat was backward, but when he jumped, his velocity relative to the water was still forwards. When his feet entered the water, they slowed down, but his torso and head maintained his forward velocity, which caused him to faceplant. Using personal experience, we assumed that the speedboat was moving at 45 kilometers an hour. Then, using our own tests, by jumping backwards, we assumed that the boy jumped at a velocity vertically of 2 meters per second and horizontally at 1.5 meters per second. We then found that even when jumping backwards, the boy's initial velocity relative to the sea was 11.2 meters per second in the direction of the boat at 10 degrees above the horizontal. This fail might not be the most comical fail, but it's certainly the biggest fail if you're considering the gravitational force that the object has. That object is Pluto. Pluto was discovered as a planet in 1930 and then excluded in 2005. This is just the start of the fail. Based upon data from NASA, we were able to find the Pluto's orbit speed and then its period, which is 248 years. Since Pluto was found in 1930 and then excluded in 2005, this means that Pluto was only considered a planet for 75 years. This also means that Pluto completed less than a third of its orbit around the Sun between the time that it was discovered and the time it was removed from the record as a planet. Now that's a pretty big fail. Thank you for watching, and we hope that these fail explanations will prevent you from failing.